these are the answers here. So wave one has the longest wavelength, right? It's the greatest distance between these two crests. And it has the longest period and the lowest frequency. So in this wave, one wave goes by in 1 second. So that means its period is 1 second and its frequency is also one wave per second. But this one, you can see one and a half waves go by in a second. So that means its frequency is 1.5, and its period would be 0.7. And of course, wave three, it has the shortest wavelength. The wavelength's only this long. It has a frequency of 3 hertz, and so a period of 0.3 seconds. So every 0.3 seconds, a wave goes by. So there are several different types of waves, but we're going to focus on wind waves. Wind waves are waves that are created by wind. So wind energy is transferred to the water via friction. So the wind blows and disturbs the water and creates waves, just like you blowing on your teeth. Wind waves can be very different sizes, all the way from like teeny tiny little capillary waves, again, like think of you like blowing on your tea, all the way up to, giant, Mavericks size surfing waves, right? So huge difference in size between different wind waves. The main thing that's going to influence how big wind waves get is the speed of the wind. So, faster wind will create bigger waves. The duration of the wind. So, how long is the wind blowing for? Is it blowing for an hour? Is it blowing for 2 hours? Is it blowing for 5 days? And the fetch. The fetch is how large of an area the wind is blowing over. So is it blowing over like 5 square miles? Is it blowing over 200 square miles? So if the duration's longer, you'll get bigger waves. And if the fetch is bigger, you'll also get bigger waves. So the way to get really big waves is high speed wind for a long time over a large area. That's how you generate these really big waves. Next up, we're going to talk about tides. So tides are just the daily rising and falling of the sea level. So you can see an example here. This is at low tide. This is at high tide. And there's a few different reasons it's good to study tides. First is shipping. So, for example, knowing when boats will be able to enter or leave a bay. Because, for example, if a boat has to go underneath a bridge, so this is actually excuse me, this is the Sunshine Skyway Bridge back in Florida. Excuse me, I burped. So this is the Sunshine Skyway Bridge back in Florida. This is like goes basically across the mouth of Tampa Bay. And it's a pretty big bridge, but we also had some pretty big boats that would come to Tampa Bay. So occasionally one would be big enough that it would need to go through at low tide when the water level is lower, so it didn't like hit the top of the boat on the bottom of the bridge. And you also want to know where you can store it, like whether you'll be able to get in and out of bay, and also whether your boat will end up like on the dry sand or not. So you want to know what, is the water level at high tide, and what is the water level at low tide. It's also important for recreational services. It affects things like surf for surfers. It also affects like scuba diving. It affects currents a lot, especially close to shore. Tides can cause really strong currents. So if you're swimming or scuba diving, you might want to avoid times when those currents are going to be really fast. It also has a huge effect on erosion and sea level rise. So if any of you have ever gone to the beach and built a sandcastle, and then you find out over the next few hours that, oh, you built your sandcastle below the high tide. Oh, there's my cat. I knew she was going to do that. You find out, oh, I built my sandcastle below the high tide line, and the water, slowly encroaches and knocks your sandcastle down. Yes, hello. Um, And so tides can also affect erosion, and they can affect flooding. Hi. Yeah, you suddenly need attention, huh? You need attention? Um, so they can, yeah, cause erosion, cause sea level rise. So for example, this is a picture from this bottom picture is from Miami. This is called sunny day flooding. And so this is flooding that's not associated with like a hurricane or a storm. It's why it's sunny day flooding. It's just caused by an extra high tide. So the tide is so high that it is flooding the streets. And in fact, like water will like come up through the storm drains and start flooding the streets because the tide is so high. And this, of course, becomes more and more common as sea level rise continues to happen. So why do we get tides? Tides are actually a special kind of wave where the force that is causing them, rather than being wind, is actually the gravity of the moon and the sun. Spoiler. but mostly the gravity of the moon. And gravity is stronger with larger masses. So larger masses have greater gravitational force and with smaller distance. So the closer things are together, the stronger the gravitational force. So you can see there's kind of a water bulge on the planet. This is obviously very exaggerated. A water bulge created by the gravity of the moon. So if we think of tides like a wave, that means high tide is basically when the crest of that wave is passing us, and low tide is when the trough of the wave is passing us. So you can kind of see this on this bottom little animated image. So the moon is creating these two what we call tidal bulges, these two like bulges of water, again, very exaggerated here, on the planet, and we are rotating through them. So this like little guide be tide, low tide, tide, low tide, high tide, low tide. So again, we're rotating through these two tidal bulges. Um, And these are caused both by the moon pulling on the water that's closest to it and then also pulling harder on the earth than the water that's on the opposite side. Again, I'll post a video if you'd like to have a more like physics in-depth explanation of how this works. So next question. We've seen the moon's gravity causes tides, but do you think there's any other factors or forces? So anything like about the shorelines, anything about anything else that affects tides besides just the gravity of the moon?